Hello everyone, it's Vicky here, and in this tutorial I'm going to show you how to turn any geometry into boxes and make it fall apart. This tutorial is split into 5 sections. 1. Scene setup, where I'll remind you the most important settings for simulations. 2. Infection, propagation or growth effect, everyone calls it differently. It's inspired by an amazing tutorial by VFX Hive, link in the description. 3. Boxes effect, where I will turn any geometry, even animated, into boxes. 4. Simulation, the fracture simulation of the boxes. And finally 5. Simple shading, lighting, and rendering. However, from section 2, you can also go to another tutorial, which is an update to a tutorial I've done 2 years ago, freezing a bird. Okay, let's get to it. Let's open Houdini, and please just keep in mind that I'm using Houdini 17.5, but most of these things, if not all, you can do in Houdini 18 as well. Okay, so first thing, I need to set my project. So I already have the project folder, now I just need to show Houdini where it is. So I click on Set Project, and then find my project folder, and accept. And then we also need to save the scene. So File, Save, and you can see that it takes us straight to our project folder if we set it correctly. If you cannot see your project folder, just click here on the left and it should also take you to your project folder. Hopefully this works. If not, then you need to go to Set Project again, okay? And I'm going to save the scene in Scenes folder and name it Infection 01. And accept. When working with any movement in Houdini, so either animation or simulation, you need to make sure that several settings are set up correctly. So let's go to the global animation options. So it's this icon here, or you can click Alt, Shift, and G. Okay, and this will open this window. And first of all, we need to change the frames per second. So I'm going to import a rig later on, which is animated in 30 frames per second. So I need to make sure that this is also 30. And secondly, there is this option here called real-time playback, and it's very, very important. So for animation, it allows us to see the animation in real time, or a bit slower depending on the complexity of the animation. It will never go faster. It will never speed up. So it's very important so that we know how fast the animation is. For simulations, however, it's even more important because for simulations, Houdini calculates something based on previous frame. So if we don't have real-time playback switched on, it's going to skip the frames and the simulation might not be correct. So make sure it's 30 frames per second and real-time playback, play every frame, but never faster than FPS. Okay, so I can save this as default and then close. Okay, so I'm just going to change the workspace type to technical, and this is just my personal preference. But also for this tutorial, you will need some options which are only available in the technical viewport. So please make sure to change from build, which is default, to technical. Okay. And I will just close this panel on the left for now, and also this one at the bottom, because my screen is quite small. And now let's set up our scene. Okay, so let me just expand this. And first of all, I'm going to create the geometry. So this is going to be the propagation or infection. Let's go inside this geometry, and here I want to drop down a grid node. Okay, so you can see the grid. Let's leave all the settings as default, so we don't need to change anything here. And then we need to drop down a transform node. So it's always a good practice to have your geometry, then transform node, and then at the end of your network, always place null node, just to keep everything nice and tidy. Okay. So now I'm going to scatter points on the geometry. So we can do that by using scatter node. Okay. Also make sure to display the last node to see the changes. Okay, and let's have a look at the scatter node options. So all these settings here stay the same. In force total count, I can reduce or add more points in the scene. So this is what we will need a bit later. And at the very bottom, you have this option called relax iterations. And we want to switch this off. First of all, when you switch it off, it's going to be a bit faster. And secondly, you can see that the points are now nicely randomly spread on the grid. So now they are more uniform, now they are randomly spread. So I just prefer this for most of my effects, okay? And now I can add a bit more points, so maybe 6,000. So depending on your computer you're working on, you might need to have lower a number of points, okay? So make sure to adjust it to your computer. Okay, so let's have a look at the effect we're going to create. So some theory first. So what we're going to do is we're going to pick one point on the grid, the first infected point. So the infection is going to start over here. And the good thing is that each point in Houdini has its number assigned to it. So this point, let's say it's 105. So it's very easy to find it. Okay, so this is our first infected point. And we're going to assign an attribute to that point saying it's infected. So the infection value is going to be 1. Then we're going to do to pick another point. Again, it has a certain number, and choose an area around it, so some search radius, and we're going to search for infected points within that area. And now there are two scenarios. So if there are no infected points in this area, we just leave these points as they were. So infected value is 0. And then we move on to the next point and do exactly the same thing. So we run through all the points and then to the next point. But if there is an infected point in that area, like in this case here, then we turn all these points into infected points as well. So this is an infected area. So all the points are infected, and the infect attribute value is now set to 1. So we have either 1, which is infected, or 0, which is not infected. What we'll do in a second, we'll write that in AttribWrangle node, is we'll repeat this action for all points on our grid. So Houdini will go one by one, point by point, and run this calculation. Okay, so first of all, we need to create an AttribWrangle. I cannot spell AttribWrangle. Okay, and this attribute we're going to, so it's attribute select start point. Okay, so we need to pick our first point, and you can either do that but by manually selecting it, so you can use this tool here on the right, or you can type the point number in here. So let me show you how to do that. You just scroll down and look for this option, so display point numbers. You click on it, and now you should be able to see that each one of these points has an assigned number. Okay, so I can zoom in and pick a number that I want. So let's just pick one random point. So maybe this one here, 2738, and I just type this number in here. So 2738 and click enter. If you don't like this method, you can also, let me delete it. You can also use the selection tool. So you click in here, make sure you have the point selection switched on, and then you could just select your point, and with your mouse in the viewport, it's very important, click enter. And now you can see that this point has been added to our group. So whatever we type here now is going to be applied only to this group, so only to this one point. Okay, let me switch off the point numbers and zoom out a bit. So you cannot tell which point is our starting point. So let's visualize it a bit better. So first of all, I'm going to open this window here, this pane here at the bottom. So there are two panes, so be careful. The first one is Python shell. The second one is geometry spreadsheet. And this is what we want. Okay, so geometry spreadsheet. And with your AttribWrangle selected, you can see all of these attributes here. So these on the left are our points. If I scroll down, you can see, yeah, the last point is 5,999. And our selected points, so 2,738, is somewhere here as well. And we also have these attributes. So we have px, py, and pz. Px is position in x-axis, py is y-axis, and z-axis. Y-axis is set to 0 because they are on the ground. So yeah, that's correct. So let's create another attribute, and we'll name this attribute infect. So we type @infect, then space equals space 1 and semicolon. Okay. The reason why I typed 1 equal sign here is because 1 equal sign means that I assign a value to this variable. 2 equal signs mean that I check if two expressions give the same value. So 1 equal sign is assignment operator, 2 equal signs are equality operators. Okay, so in maths you usually use 1 sign, which in coding is actually represented by 2 equal signs. All right, so now we can see that we have another attribute added here in our geometry spreadsheet, and it's called infect. So this is how we called it. You can also name it however you want. You can name it cat or whatever you want. And now when you click on it, it will order our point. So the first point will be with the highest value. And you can see that this point has a value of 1, which means it's infected. And you can also see this is our point. So 2738, yeah, that's our group point. Brilliant, but we still cannot see it in the viewport. So let's add another attribute here. Attribute CD, which stands for color. So attribute capital C, lowercase d, then again space, 0, space, and this time color is a vector, so we need to type it in a bit different way. So we need to use these braces and then type 1, comma, 0, 0, and close braces and semicolon. Okay? Brilliant. So now you can see that we have one more attribute here called color, and we have 3 values. So we have red, green, and blue. And you can see red is set to 1, which means we are using 100% red. Green is set to 0, so we're not using green at all. And blue is set to 0 as well. So we're only using the red color. And this is exactly what we type here. So red, green, and blue. So red is 1, green is 0, blue is 0. So now you can see it's much easier to find our point because it's this red dot over here. Oops, I just lost it. Yeah, it's right here. So what you can also do, you can change the color, maybe to green, if green is your favorite color, but remember which color you used because we will need it later on. And only use one channel, okay? We don't want to mix channels. So you can use either red, green, or blue just to make our lives a bit easier. So in the first AttribWrangle, we told Houdini which point is infected. In this visualization, it's point 105. Now we need to create another AttribWrangle, which will tell Houdini how to calculate, how to find the infected point and infect other points. So there are a few things we need to look at first. So first of all, different data types in Houdini. So there are 4 main data types that we will use today. First of all, an integer. So it's a number that is not a fraction, it's a whole number, so 1 or 157. And you can see these numbers quite often in Houdini. So let's go back to our scene. So for example, in your grid, if you select it, you can see that we have the number of rows and columns, and we cannot change this to a fraction. We only have whole numbers, so 1, 2, 3, 4, 5, and so on. Okay, so rows and columns, these are integers. Okay, the same thing happens in scatter nodes. So we can force total count, but these can only be whole numbers. We cannot use fractions because we cannot have 1.5 points. All right, so this is our first data type, so integer. The second data type is a float, so it's a value that allows for decimal numbers. So, for example, 0.5, so half, or minus 3.14159265. So all of these can be our floats. And you can also see that very often, for example, on your grid as well. So size, you can change the size to 10.5 or 10.1. Okay, so you can use fractions. The same in transform node, you have uniform scale. So it's a float as well. Okay, one value, which allows for decimal values. Okay, and then we have even more advanced, well, even more complex values, which are vectors. So vectors are typically a collection of 3 values, and they are separated with a comma and stored in braces. So you can see an example here. And this is what we used for our RGB. So we used 1, 0, 0. So this was a vector. A vector is also a position. So in position, you can see we have 3 values. So we have X, Y, and Z. These are 3 values. So translation, rotation, these are vectors. And finally, we have something called string. So it's a non-numerical value. It can be, for example, a text. So it can be a file path or SOP path. And you can see these, especially when you're rendering and choosing where to save your file. So let's create another AttribWrangle. And plug in the first one to the first input of the second one and display it. So in the first one, we chose our starting point. The second one is going to search for this point and infect the point. So the second one is where we create the infection effect. All right, so we're going to start with writing if our attribute infect is set to 0, do the following. So we can type it by if open brackets @infect, so our attribute infect, space equals space 0, close brackets, and open braces. So the reason why I use 2 equal signs is because I'm comparing these 2 values. So I'm checking if this value over here, so attribute infect, is equal to 0. In our first AttribWrangle, we used 1 equal sign because we were assigning a value to the infect attribute. So we said infect attribute for this point from now on will be set to 1. Whereas here, we're comparing the values. Okay? So if attribute infect is equal to 0, do the following. So we're going to run a float search. So float space search equal to. So now we need to specify what area we want to search in. And we're going to do that by creating a slider. So we can type CHF. So CH stands for channel and F is float, because our area does not need to be an integer. It can be a fraction. So we can search maybe 0.1 units around the point. And then open brackets, inverted comma, and now type the name of the slider in here. So I'm going to name it search _ radius. And again, inverted comma, close brackets, and semicolon. So every time you finish the line or finish some formula, you type semicolon. Okay, also remember in the name, you need to use underscores instead of spaces. It's very important. And once this is done, click on this button here on the right, and then scroll down, and you will be able to see your slider. And you can also see that this slider allows for fractions and decimal values. So it's not only whole values, we can also use fractions, which is great. That's exactly what we wanted. So again, let's Click enter. And now we need to create the second slider. So first of all, we have our search radius. And second thing is how many points in this area we want to infect at once. So let's type int. So this time it's going to be an integer, not a float. Space num of points. So it's number of points. You can type whatever you want in here. And again, space equals space. And we're also creating a slider, but this time it's an integer. So chi, open brackets, inverse comma, and now type your name, the name of the slider again. So number of points. Okay, so you can see it's very similar to what we typed in here. Instead of float, we're using an integer. Then, of course, we have different names. And then we're creating a slider with this name. And again, we click on that button, scroll down, and now we can see two sliders. So number of points only allows for whole values because it's an integer. So we cannot have 1.5 points. You only can have 1, 2, 3, and so on. So now we need to create another integer. So int space, and we're going to name this one stored points. And this is going to be an array. So when you see these closed square brackets, it means that Houdini is saving it in his memory. Okay, so it's integer, we name it stored points, and then it's an array. And then space equals space, and we're going to use something called nearpoints. So it's a formula. And when you start typing nearpoints, you will see these two options in here. So we have nearpoint and nearpoints. And the second one is the one that we want to use. So the one with S, because we're looking for more than 1 point. Every time you write something, you write a formula, a function, you're not sure how to use it, you can always go to SideEffects Houdini website and check what this function does. So nearpoints is a vex function, and it finds all closest points in a geometry. The one that we're going to use is this second one. So you can see that we have many iterations. So first of all, it asks us for geometry. So we need to type an input number. So if I go back to Houdini, you can see that we plugged in everything to the first input. And in Houdini, input number starts with 0. So first input has the number 0. So let's type open brackets 0. Okay. The second thing is a vector. So you know that a vector must use 3 values in braces, like RGB. But in this case, we can also use @p, which refers to point position. So point position has 3 values, x, y, and z, so position in x, y, and z axis. And if we type @p, it's going to be different for each point. So this is exactly what we want. Okay, so we type @p, make sure it's capital P, comma, space, and third value is maximum distance. You can see it's a float. And in our case, the maximum distance is the slider that we created. And let's find our maximum distance slider. So our maximum distance slider is called search. So even though in here you can see it's called search radius, this is the name that Houdini is using. So that's what we need to type in here. Okay, so we type search. Make sure you type it exactly the same way as it's spelled in here. Then comma, space. Last value we need to use is an integer, and it's maximum points. So how many points do we want to run this through? And again, in our case, it's the slider. And the second slider is number of points, and we named it num of points. So this is what we need to type in here. So num of points. And then we close brackets. Okay, so what this formula does is it takes points from the first input, so from our scatter node. Then it uses their position, and it searches within this radius, so whatever we type in here, whatever we choose in here, and searches for this number of points. Great. So now let's again click enter and type integer, so int pt, so point, semicolon. And let's type another formula. So this formula is called foreach. When I start typing, you can see foreach. And again, let's have a look at the side effects guide. So we use nearpoints, now foreach. So foreach loops over the item in an array with optional enumeration. So first value is the element type. In our case, it's point. And we can write it as pt. The second is an array. So we created an array here. It's called stored points. So we need to open brackets. First we type pt. And then we type stored point because this is our array. So we already told Houdini what to do if infect value equals to 0. Now we need to tell what to do when this value equals to 1. Okay, so we need to type if, open brackets, and we're going to use a point function. So what a point vex function does is it reads a point attribute value from a geometry. So for each point we have a different attribute value, and this is what it reads. Okay, so first we need to use the input, so we know already that it's 0. Then we'll use string. So in our case is the attribute name that we want to reference, so infect. And then finally we have a point number, which is an integer. So again, we can just type pt to check the current point. So we open brackets and first the input, so 0. Then we type the name of the attribute, so it's infect in reversed commas. And then finally pt for the point. Okay, and then equals to 1. So we're checking if this equals to 1. If it equals to 1, then do the following. And now we need to do exactly the same thing as we did in our first AttribWrangle. So if the infect value equals to 1, then we need to change the infect value, the infect attribute to 1, and also the color to red, or whichever color you have chosen. So we just type here at infect equal to 1, so change the value to 1, and also at color, so cd equal to 1, 0, 0, so red color. Okay, and semicolon. And now we need to close all of these braces. So let's type the first one, and you can see this one is highlighted. Then the second one, we just close this one over here. And the last one is this one over here. When I play our scene now, you can see that nothing happens. This red color is not spreading, the infection is not spreading. And this is actually correct, because at the moment, Houdini has this function, but it doesn't know how to execute it. So in simulations, we always have a brain. So we have a solver for each type of simulation. So flip solver, pyro solver, and so on. And we also need a solver in here. So let's just type tab and create a solver. And if I zoom in, you can see this is this little brain icon. And this means this is the brain of our scene. So this is what makes all these calculations possible. So let me show you how it works. I created this very short network. So first we have, let me just close that. We have a sphere, okay? And then we have a transform node. So in this transform node, I typed at p plus 1, which means the position of the sphere is attribute position plus 1. So at the moment, you can see that my sphere is not moving. It just moved 1 unit to the top. So this is the initial position, and then it moved 1 unit to the top, but it's not animated. Whereas if I go inside the solver and paste the same transform node in here and plug it into previous frame. Okay, so you can see I have exactly the same formula. And then display the solver, bypass the transform. Now you can see that when I play, the sphere goes up. So why is that? This is because in your solver, you have something called previous frame. And this allows Houdini to calculate each frame based on a previous frame. By the way, you will not see the animation, you will not see what's happening inside the solver. You need to go back to your SOP network, to your geometry. Okay, so when I plug in my transform node to the previous frame, on the first frame, it's going to just move my sphere to position 1. On the second frame, okay, on the next frame, it's going to move the sphere 1 unit up, and so on, because it bases its calculations, it bases its movement on the previous frame. If you want to learn something more about solvers, again, Side Effects Houdini is a very good website, so sideeffects.com, and then you can type solver or whatever you're looking for in here, and you'll find a lot of useful information. You can also scroll down, and at the bottom you will see examples of scenes, so you can load the scene and see how it works. It's also very, very useful. Another website is CG Wiki, and if you want to learn about SOP Solver even more, there are a lot of very, very good examples, also some tricks and life hacks, I would say, for using SOP Solver. So it's also a very, very useful website, link in the description. So now if we want our simulation to work, go back to our scene, we need to plug in the solver to our attribute, to the first attribute, and then we'll move this second attribute inside the solver. So I select it and click Ctrl X to cat or Command X on iOS, and then go inside the solver and click Ctrl V to paste. Okay, so if I select it, you can see, yeah, it's our second attribute. So we have all of that here, we have the sliders and everything. And then we plug in previous frame to the first input. It's very important because everywhere here we referred to the first input, so input number 0. So make sure you plug it into the first input, and then also display AttribWrangle. Now we can go back to our geometry, display the solver. Now when you play it, okay, again, nothing happens, but at least you can see that our timeline changes color to blue. So this means we have some type of a simulation. So Houdini creates cache data on our computer. So let's go back to the solver. And the reason why nothing is happening is because my search radius and number of points is set to 0. So I need to increase the search radius. You can also type your own values here. So you're not limited to 0 to 1. You can type any values in here. And I want to increase the number of points as well. Okay, and then I can go back to my scene, and play it again. And now you can see how this propagation works. So every time you want to adjust something, maybe you want to make it a bit slower, you can again go back to the solver, reduce the number of points. Okay, now we have 2 little points. And it will be a bit slower. And finally, the last thing left is deleting these not infected points, so the white points. So let's drop down a delete node, delete, make sure to display it. And now we need to change several things here. So first of all, entity. Entity is points because we're deleting points. Then operation type, we want to change it to delete by expression. So you can actually easily delete all the non-infected points because their infect value, so if I just switch on select solver and then open geometry spreadsheet, you can see that we grouped these points into 2 groups with infect value of 0 and with infect value of 1. And this is what we're going to use here in the delete node. So let's go back to the delete node, and in the expression we type @infect equals to 1. Okay, so we deleted all the points that equal infect value equals to 1. So we can change the operation type now to delete not selected, so delete everything apart from these points. Okay, and it's working. So after the delete node, we want to drop down null just to make sure we close our network, and I'm going to name it out infection. So everything up to this point, so up to the null, is our infection. Okay, so we've done it for the grid, but now we want to apply it to a 3D geometry. So let's go back to the object level, and I will duplicate this network. So select the network, hold down Alt, and drag it to the side. So the first one, let's rename it to Propagation Grid. The second one is going to be Propagation 3D Object. Okay, and we can hide the grid and go inside the Propagation 3D Object. I don't need this group anymore, so I'll just quickly delete it. All right, so let's go back to the beginning of our network. So here we have a grid. We don't want this grid anymore, so just select it and press delete. And instead of this grid, I'm going to use a file. And after a file, we always want to use a convert node. Well, always, in most of the cases, it's always a good practice to use convert after the file. And then we can plug it into the transform node. So in the file, what I want to do is use my character rig. So I downloaded this one from Mixamo. I'll just import it. You can use your own 3D geometry, or you can use an animated rig as well. So Mixamo is this website here where you can download rigs and download animations, and it's a very, very useful website. I use it all the time for animations. Okay, so we have the rig. It's very big, so let me just click Control F to find it. Okay, so that's my rig. It doesn't have any animation at the moment, and I'll tell you why in a second. Let's first set it up for this geometry. Okay, so I select the convert as well, then transform, so everything is fine. And then I have the scatter node. So you can see that the scatter node only scatters points on the surface of this geometry. It doesn't scatter any points inside the geometry. It's a 3D geometry, so it would be nice to have points inside as well. So instead of using scatter, I will use something called points from volume. So points from volume, and I just plug it in here. And here, make sure you're using the first input, and then I can just remove the scatter node. And points from volume, if I display it, might take a while. Okay, it's worth saving at the moment, so Control S to save. And if I display the points from volume and zoom in, you can see all these black dots. These are our points, so we have a lot of points. So I need to reduce this number. And in points from volume, we can reduce number by increasing point separation. So point separation is how far from each other or close from each other are the points. So if I increase this value, it means the points are further away. So I will not have as many points as with low value. So maybe, okay, I'll use even more, maybe to 1. Okay, that seems all right. Yeah, so you can see we have all these points inside our geometry. Maybe let's reduce it even more. Okay, then we have our AttribWrangle. And in the AttribWrangle, you will probably have to select your point again. Sometimes you might find that this point is actually somewhere inside your geometry. It might be in the place that you don't want it to be. So it's always good to choose a new point. Okay, but I'll just leave it. I'll just let it be there. Okay, and then we have the solver. And now when I play it, Okay, it's not working. And I also, in the solver, I need to increase the radius, because if I go back to my points from volume, you can see that point separation is 1.5. So all points are at the distance 1.5 from each other, whereas in the solver, we use the search radius of 1. So there's nothing in that area. So it needs to be the minimum of 1.5. So I'll change that to 2. And now, hopefully, you will see the difference. Yeah, okay, great. And now I can also switch on the delete node and out infection and play it again. And now we should only be able to see the particles, the points.